Okay, so this next video is on, well, this is covered in chapter 2-5 in the textbook, and this is going to be on position, displacement, and distance traveled. Okay, so first off, so position is just the location of an object. So, and this is with respect to a frame of reference, which you could think of as a coordinate system. So it's an origin and a way of measuring things. So, and again, this is easy. Remember in chapter 2, we're just starting with one-dimensional motion. So for one-dimensional motion, motion along a line, we just need one coordinate. And typically we'll just call this the x coordinate. And then if we have an object's position in x, well, and then it moves to some other position in x, we can define a displacement. So displacement is the change in position. So, and this is denoted by delta x. So remember, delta in math just means the change in something. So delta x is the change in x position. So, and well, there's different ways you can denote this. So you can say this is the x coordinate at some time 2 minus the x coordinate at some time 1. Or you can define this as x final, so the little f is final, and the little 0 means initial, or sometimes instead of a 0, it's an I. So this is the final position minus the initial position. All right, so displacement is a vector, so it has both a magnitude and a direction. Now, fortunately, since we're just using one-dimensional motion, the direction part is actually pretty easy because you can give it by a sign. Right? If all you can move is along a line, well, and if it's a horizontal line, you can either move to the left or you can move to the right. So there's only two possibilities, so we can denote it by a sign. And the convention is, so just like you'd think with a number line, so if you've got a horizontal line, to the right is positive, to the left is negative. And if it's vertical motion, up is positive and down is negative. Although that's just a convention, so you may have good reasons for picking something else. Okay, so now something slightly confusing, so this idea of distance traveled. So distance traveled is the total length or the total distance that an object moves, or you could think of it as the path length. Now this gets a little bit tricky because it's not necessarily just the magnitude of the displacement. So remember, the displacement was our final position minus the initial position. And sort of the classic example to see how these two can be quite different is, imagine you're running along a track. So here we've got a picture of a track. Let's say you're starting at some position here, and let's say you run around the track all the way around and you end up right back where you started. So you make one complete trip and you end up right back where you started. Well, your displacement is your initial position minus your final position minus your initial position, but those are the same. So since those are the same, your total displacement is 0. Now, however, the distance traveled is not 0. It's actually the total length of this path that you ran as you traveled all the way around. And if it's a standard track, it's going to be something around 400 meters. Of course, it'll depend on exactly what your path was, but somewhere in the neighborhood of 400 meters.